Okay guys, so in this video we're going to take a look at how to simplify radical expressions. So we're going to deal with our factor trees. So 48, the factors of 48 that I can think of off the top of my head are 16 and 3. 16 breaks down into 4 and 4, so this becomes 4 square roots of 3. You could have used 12 times 4, you could have used 8 times 6, and it still should break down the same way. Fifth root is 64. So 64 is 32 times 2. And 32 breaks down into 1, 2, 3, 4, 5. Oh, 5 2s, sorry. So we should know that 2 to the 5th is going to be 32. So we can pull that on the outside of the root, and we get 2 times 5th roots of 2. So whatever the root index is, that is what we're going to pull on the outside. Okay, you have to have that big of a group. Okay, square root of 18. 18 breaks down into 9 and 2. 9 breaks down into 3 and 3. We're going to bring that on the outside, and I'm going to leave a little bit of space to deal with the m's. Okay, so I have a 2 left on the inside. Now, your root index is 2, okay, because it's square root. So how many times does 2 go into 3? Well, it goes in once with a remainder of 1, okay? And that's how we're going to deal with roots. Fourth root of 32, okay? So 16 and 2, okay, and 16 breaks down to 2 times 2 times 2. Okay, so 2 to the 4th power gives you a 16. And that's what we're going to break down like that. Okay, so we're going to pull that on the outside. And we're going to leave 4th root. And I'm going to leave a 2 on the inside because I have a 2 left over on that factor tree. Now, how many times does 4 go into 6? Well, it goes once. So I'll pull the X. And I have 2 left over on the inside. Okay, cube root of negative 64. Okay, cube root of negative 64 is negative 4. Okay, it goes in evenly. If you didn't know that, you could do a factor tree let's do 16 and 4. So 2, 2. So 2, 2, 2, 2, 2, and 2. Okay, so we're doing cube roots, so we need groups of 3, and it comes out evenly. The negative, so you can take a cube root or an odd root of any negative number. Okay, cube root of a to the 6th is a squared, and cube root of b to the 7th. Okay, so 3 goes into 7 2 times, with 1 remaining, and that's what your answer looks like. Okay. 5th root of negative 32. We've already talked about the 5th root of 32 is going to be 2. Okay, 5 goes into 5 evenly, so x goes into it once, and 5 goes into 10 twice evenly, so it's y squared. Okay, 4th root of 256. So we probably need to actually do this one out. Let's see. What are the 2 and, let's see, 256 divided by 2 is 128. Okay, 128 divided by 2 is 64. And 64 breaks down into 8 times 8. And we just did this. Okay, so we're looking for fourths. So you gotta have groups of 4. So the 4th root of 256 should be 4. So your answer comes out to be negative 4, because you get that negative on the outside. Okay? Now, when we multiply square roots, sometimes it's better to simplify them first. We've already kind of done this before, so 24 breaks down to 6 and 4. 3, 2, 2, 2. Okay, so I can pull a 2 on the outside. So this becomes 10 square roots of 6 times 8 breaks down to 4 and 2, 2 and 2, 2 square roots of 2, so it's 6 square roots of 2. Okay, when we multiply the numbers on the outside, 10 times 6 is 60 square roots of 12. Now, so we're going to multiply the 6 times the 2, and you get the 12. Now, 12 is going to break down to 4 and 3, and 2 and 2. Once again, you can pull a 2 on the outside, so it becomes 120 square roots of 3. Okay, next one, cube root of 48 over cube root of 2. Okay, 48 divided by 2 is going to be 24, so cube root of 24. And then we got to break that down, so it's going to break down to 8 and 3. And 8 is going to break down into 2's. So cube root of 8 gives you a 2. So this becomes 2 cube roots of 3. Okay, now when you multiply the same root by each other, so the root index of 4 and root index of 4. So say we're doing like square root of 2 times square root of 2. Square root of 2 times square root of 2 is square root of 4, which gives you 2. Now, you could also just say that square root times a square root, or a fourth root times a fourth root, the root goes away, okay, if you want to do this quickly. So 4 times 8 is 32. A squared times 8 to the 4th is 8 to the 6th. When we multiply exponents, we add them. B to the 5th times B to the 10th is B to the 15th. Okay, cube root of a fraction. Cube root of 27 is 3. Cube root of 8 is 2. Okay, now when you add and subtract radicals, you have to have the same thing underneath the radical. The radicand has to be the same. So we're going to say 2 square roots of 3 plus 3 square roots of 3 is 5 square roots of 3. Okay, now in order to add and subtract radicals, they have to be the same radicals. So we're going to break down each one. So 50 breaks down into 25 and 2, and 5 and 5. So that becomes 10 square roots of 2. 16 and 5, and that breaks down to 4 and 4. So it's 4 square roots of 5. And 125 breaks down to 25 and 5. 25 breaks down to 5 and 5. So it's 15 square roots of 5. Now make sure if you're bringing something on the outside, you're going to multiply it by whatever number's on the outside already. So the only thing we can do is we can combine these. So 10 square roots of 2 plus 11 square roots of 5. That's it. And I'm just going to double check my answer. Make sure I'm right. Because I'm doing this a little quickly. Yep, that's right. Okay, fourth root of 80. 80 breaks down into 16 and 5. And then breaks down into 2, 2, 2, and 2, because the fourth root of 16 gives you 2. So this becomes 24 fourth roots of 5. This doesn't break down, plus 18 fourth roots of 5. Add them together, you get 42 fourth roots of 5. Okay, last one. 16 breaks down to 8 and 2, and that 8 can break down into 2 cubed. Okay, so we get cube root of 2 plus, I'll get a 2 on the outside, plus 54, 9 and 6, 3 and 3, and 3 and 2. So we can pull out a 3 there. And we're left with the 2 on the inside. And we can combine our radicals because we have the same thing underneath the radicals. So it's 5 cube roots of 2. Okay, so this has been solving simple radical expressions. Make sure that you do your factor trees. I also suggest that you memorize all your squares, your perfect cubes through at least 5 or 6, and your perfect fourths through 3 or 4, and then your fifths at least a few of them, okay? Especially the 2s, those show up a lot. So make sure that in order to bring something on the outside, you're looking at the root index, and that tells you how many numbers you have to have for your grouping. Okay, if we pull it to the outside, we're multiplying it. In order to add and subtract radicals, they have to have the same common radical, okay? Just like terms. Okay, so if you have any questions, feel free to reach out. Thanks, and have a good night.